The night sky feels black almost automatically. It's such a familiar impression that most people never challenge it. You look up and your brain accepts the scene as normal, a dark backdrop, scattered stars, silence. And yet, from a scientific point of view, that darkness is not the obvious outcome. Not at all. Because the moment you treat the universe like a real physical system, a simple question appears simple in wording, brutal in implication. There are billions of stars and galaxies in every direction. Why isn't the sky flooded with light? This thought is older than modern astronomy. It existed long before telescopes, long before space probes, long before anyone could measure galaxies. Even in classical reasoning, people understood something unsettling in an infinite, static universe, uniformly filled with stars. Every line of sight should eventually hit the surface of a star. Not might, not sometimes, eventually always. And if every direction ends on starlight, the entire sky should glow. Not faintly, not gently. It should be bright, nearly as bright as the surface of an average star dot in that model. True night would be impossible. Darkness would be an illusion. That contradiction became known as the dark night sky paradox, often called Olber's paradox. But the paradox is not a trivia question, it's a diagnostic symptom. It tells you that the intuitive picture an eternal cosmos filled forever with shining objects doesn't match how reality is built. So, the darkness of space is not the absence of light in some childish sense. It's a consequence of time, distance, evolution, structure, and the fact that the universe is not a frozen stage. The first correction to our intuition is the one people underestimate because it sounds basic. Light has a speed limit. Light does not fill space instantly. It travels. It is unbelievably fast, but it is still finite. And that single fact turns astronomy into a kind of time machine. When you see the sun, you see it as it was a little over 8 minutes ago. When you see a star 1,000 light years away, you see it as it was 1,000 years ago. When you see distant galaxies, you see them as they were millions, sometimes billions of years ago. So the universe you observe is not a single snapshot of now. It's a mosaic of different eras. Every photon carries a timestamp. Every view is history. And here's the key. If the universe has a finite age, then there is a boundary to what can be seen, not a wall in space, but a horizon in time. A region beyond which light simply hasn't had enough time to reach us since the beginning. You can call it an observational horizon. You can call it a time frontier, but the meaning is the same. Beyond a certain distance, the sky is dark, not because nothing exists there, but because information from there hasn't arrived. That alone weakens the old, infinite, bright sky logic. Because Olber's paradox assumes infinite time for light to accumulate. Reality does not grant infinite time. Reality gives you a universe with a history. Now add the second reality. That breaks the eternal lamps fantasy. Stars do not shine forever. They are born. They evolve. They burn fuel. And they stop. Some collapse quietly into dim remnants. Some explode. Some become objects that barely emit visible light at all. Even long-lived stars have a lifespan. That means the universe is not filled with permanent light bulbs. It's filled with temporary fires. So even if you imagine enormous numbers of stars, their light is not guaranteed to be present in every direction at every moment. A star might have existed in that direction and died long before its final light could meaningfully brighten your night sky, or its light might be so diluted by distance that it falls below detection, below vision, and that introduces a subtle but deadly correction. Light doesn't pile up, like dust. It doesn't sit in space and accumulate into a permanent glow. A photon either reaches you, or it doesn't. If it misses you, it continues on. It does not leave behind a bright residue. Now comes a third truth that quietly destroys the idea of a uniformly lit sky. Matter is not evenly spread. Stars gather into galaxies. Galaxies gather into groups and clusters. Clusters and groups stretch into filaments, and between these structures are vast cosmic voids, regions where the density of matter is extremely low. So space is not a perfectly filled ocean of stars. It is a structured web, a skeleton of bright nodes, connected by long, thin strands, surrounded by enormous darkness. If you stare through a cosmic void, you are looking through a region that does not contain enough nearby light sources to build a bright background. The universe is not homogeneous in the way Olber's paradox pretends, but even these three ideas, finite speed of light, finite lifetimes of stars, and the uneven distribution of matter still aren't enough unless you add the deepest factor of all. Space itself changes. The universe expands. This is where intuition collapses, because people picture expansion as objects moving through space like bullets. That's not the real meaning. Cosmic expansion means that, on large scales, the distance between major structures increases because space itself stretches, and light traveling through stretching space gets stretched. 2. Its wavelength grows, its energy drops, its color shifts toward longer wavelengths, toward red, then infrared, then microwave, then radio. This is cosmological redshift. So a large fraction of light emitted by very distant galaxies does not arrive as visible starlight. It arrives as radiation your eyes cannot detect. The energy is still real, and instruments can measure it, but to human vision, it becomes darkness. That means the night sky is not empty, it is full of light that has been transformed into invisibility by the physics of the expanding universe. The sky is dark, partly because the universe is dynamic, not static. It is stretching, and that stretching dilutes visibility. So when you bring it all together, the darkness stops looking mysterious. It becomes the natural result of multiple constraints working at once, a universe with a finite age. So light has not had infinite time to arrive, stars with finite lifetimes. So sources switch on and off through cosmic history, a cosmos arranged into structures with huge voids, not uniformly packed, an expanding space that redshifts and weakens distant light, pushing it out of the visible spectrum. Individually, each factor helps. Together, they answer the paradox. They explain why the sky is not a blazing sheet of white. And something even more interesting happens when you accept that answer. The darkness becomes meaningful. It becomes evidence. A black background is not just nothing. It is a fingerprint of the universe's age, a signature of cosmic evolution, a quiet confirmation that the cosmos is not eternal, not static, not perfectly uniform, not frozen in place. The night sky is a message, not a message written in bright letters, but written in the silence between them, in the gaps, in the darkness itself. And once you see that, you stop treating the sky as a simple backdrop with stars painted on it. You start treating it as a physical document, a record of how reality behaves, a proof that the universe is still unfolding, and that what you call dark is often just the boundary of what can reach you. Its darkness were caused only by distance. The problem would already be solved, but distance alone is not enough, because even within the visible universe, well inside the region where Light has reached us, the sky remains overwhelmingly black. That means something deeper is happening. To understand it, you have to abandon the idea that light behaves like a substance that fills space. Light does not accumulate. It does not pull. It does not form a permanent luminous background simply because many sources exist. Every photon follows a path, and unless that path intersects your eyes or a detector, it contributes nothing to what you see. This seems obvious, but its consequences are counterintuitive. Imagine billions of stars scattered across unimaginable distances. Each one emits enormous energy, yet that energy spreads outward in all directions. As it spreads, it obeys a simple geometric rule. The farther light travels, the more area it must cover, and that area grows faster than intuition expects. A star does not illuminate space evenly. Its light expands as a growing sphere. As the radius of that sphere increases, its surface area increases dramatically. The same amount of energy is now distributed across a much larger surface, which means the energy per unit area drops rapidly. Double the distance, the brightness does not have. It collapses on cosmic scales. This effect is devastating to visibility. A star that would blind you up close becomes effectively invisible at interstellar distances. At intergalactic distances, even entire galaxies fade into insignificance. So when people imagine billions of stars lighting the sky, they unconsciously imagine brightness adding up linearly, but light does not add up that way. It thins out. Most stars contribute so little light individually that their combined effect never crosses the threshold of perception, not because they don't shine, but because geometry defeats them. And this leads to another overlooked limit. The human eye is not an infinite integrator of photons. Your vision does not patiently collect light forever until an image forms. It has thresholds. If the photon flux is too weak, the signal simply never registers. And no matter how many faint sources exist, millions of ultra-weak signals do not automatically combine into brightness. Below a certain level, they are effectively zero to perception. So, even if distant stars exist in absurd numbers, their individual contributions are too diluted to matter visually. Darkness is not emptiness. It is sub-threshold reality, but geometry and perception still aren't the full story, because light does not travel through an empty, passive medium. As photons travel, they do not stay frozen in the conditions of their birth. They interact with expanding space, evolving matter, and shifting reference frames. And this aging matters. A photon emitted billions of years ago was born into a universe that was smaller, denser, and hotter. As the universe expanded, that photon's wavelength stretched. Its energy dropped. Its character changed. By the time it reaches you, if it reaches you at all, it may no longer be the kind of light you recognize as light. This is why the early universe does not appear bright to your eyes. It is not because it lacked energy. It was overwhelmingly energetic. But that energy has been stretched into microwave background radiation, a cosmic afterglow invisible to human vision, yet measurable everywhere. So when you look into a dark patch of sky, you are not seeing nothing. You are seeing the result of time diluting energy, of expansion rewriting radiation, of physics quietly converting brilliance into subtlety. And there is another subtle effect most people miss. Light is directional. Photons move along paths. They do not spread backward. They do not fill space evenly once emitted. This means there is no mechanism that naturally builds a permanent luminous fog across the universe. Once light passes your location, it is gone. It does not linger. The cosmos does not store illumination. It transmits it. This is why the idea of light accumulating over infinite time is physically wrong. Time does not pile photons into brightness, it lets them pass. And that final realization collapses Olber's paradox completely. The paradox assumed infinite stars, infinite time, static space, permanent light. Reality provides none of those. Instead, we live in a universe where time has a beginning. Stars are temporary, space expands, light spreads, weakens, shifts, and escapes. Darkness is not an error in the model. It is the model working correctly. And once you accept that, the night sky changes character. It stops being a mystery caused by missing light. It becomes a demonstration of cosmic limits. Limits of speed, limits of lifespan, limits of perception, limits of reach. The black sky is not silent because nothing is happening. It is silent because most of what is happening lies beyond your biological and physical window. Darkness is not emptiness. It is filtered reality. And in that sense, every dark region of the sky is not a void, but a boundary, a place where information exists, just beyond your ability to see it. Up to this point, darkness can seem like the passive result of limits. Limits of distance, limits of perception, limits of energy. But there is another layer, one that turns darkness from a passive outcome into an active consequence of how the universe evolves. To see it, you have to stop thinking of the cosmos as a static stage where events happen. The universe is not a container, it is a process. And one of the most important properties of that process is expansion. For a long time, astronomers believed space itself was fixed. Stars moved, galaxies drifted, but the background, the stage, was assumed to be still. That assumption was wrong. Modern cosmology shows that space itself stretches, not locally, not on small scales, but globally, across the largest structures. The distances between galaxy clusters increase not because everything is flying outward explosively, but because the metric of space itself evolves. And light is forced to participate in that evolution. When a photon travels through expanding space, it does not remain unchanged. Its wavelength stretches along with space. As the wavelength increases, the photon's energy decreases. This is not absorption. It is not scattering. It is not loss in the classical sense. It is transformation. A photon emitted as visible light can arrive as infrared. Infrared can arrive as microwave. Microwave can dissolve into background radiation. So the farther light travels, and the longer it travels, the less likely it is to remain visible. This means something deeply counterintuitive. The universe can be filled with radiation and still look dark. The sky is not black because light is absent. It is black because light has been moved out of view. And this effect is not small. It dominates the appearance of the cosmos on the largest scales. When we look toward the most distant regions observable today, we are looking back toward an era when galaxies were forming, stars were igniting, and matter was far more concentrated. Yet those regions do not blaze in visible light. Why? Because their photons have been stretched for billions of years. By the time they arrive, they no longer stimulate the cells in your eyes. So darkness becomes a signal. It tells you how much the universe has expanded since that light was born. This also means the night sky is not timeless. It is evolving. Billions of years ago, the visible sky would have looked different. Billions of years from now, it will look different again. As expansion continues, more and more galaxies will slide beyond the reach of visible light, not because they vanish, but because their radiation slips into wavelengths we cannot see. In the far future, even nearby galaxies will fade. Not suddenly, gradually, silently. The night sky will grow darker, not emptier. And this introduces a powerful idea. Darkness is not the opposite of light. It is the end state of cosmic communication. Now consider this from another angle. Even if expansion did not exist, even if space were static, darkness would still dominate. Why? Because the universe is not infinitely old. Time matters. Light has only had a finite amount of time to travel. Stars have only had a finite amount of time to shine. Energy has only had a finite amount of time to propagate. There was a moment when there were no stars at all, no galaxies, no visible light. After the universe began, there was a long era before the first stars ignited, an era of darkness. Then stars formed, light emerged, but it did not instantly fill everything. That light is still spreading. So even today, when you look into deep space, you are looking into regions whose local cosmic history never included visible stars at the moment their light was emitted. They are not dark because stars never existed. They are dark because stars had not yet been born then. The sky, once again, is a time map, and this time map is uneven. Some directions look back to eras rich with stars. Other directions look back to eras before starlight became common. So even within the observable universe, brightness varies wildly not because of distance alone, but because of cosmic history. Now combine this with stellar evolution. Stars do not appear evenly across time. They form in bursts. They cluster, they peak, they decline. There were eras when star formation was intense, when galaxies blazed with activity, and there are eras when star formation slowed. The present universe is quieter than its past, so the total light output of the cosmos changes with time. The sky reflects that change. Darkness is partly a fossil record. And then there is geometry again, this time on the scale of entire galaxies. Galaxies are thin. Stars occupy tiny volumes relative to the vastness around them. Even within a galaxy, most of space is empty. So even when you look through a galaxy, you are mostly looking between stars, not at them. This means brightness does not stack efficiently. Lines of sight pass through emptiness far more often than through stellar surfaces. That inefficiency is fatal to the idea of a bright sky. Light sources exist, but they occupy a vanishingly small fraction of space. They are islands in an ocean of vacuum. So darkness is not surprising. Brightness is. Every visible star you see is statistically rare. A coincidence of alignment, distance, and timing. A successful delivery of photons across cosmic obstacles. Seen this way, the night sky becomes almost miraculous, not because it is dark, but because it contains any visible points at all. Each star is evidence that light survived expansion, distance, dilution, transformation, time, and that survival is temporary. Given enough cosmic time, even those points will fade. Not explode, not vanish, fade. The universe is moving toward a state where visible light becomes increasingly scarce, not because energy disappears, but because it spreads beyond relevance. So darkness is not a problem to be solved. It is the direction of travel, and that changes the emotional meaning of the night sky. It is not an empty void with occasional lights. It is a dynamic system, gradually shifting energy into forms we cannot see. What looks like silence is motion. What looks like nothing is process. The black background above you is not the absence of activity. It is the signature of a universe that evolves faster than light can keep up with visibility. Darkness is not ignorance. It is a measurement of age, of expansion, of limits. And once you understand that, the question is no longer, why is the sky dark? The real question becomes, how long will it stay bright at all? At this stage, darkness no longer looks accidental. It looks inevitable. But there is still one more layer, one that connects everything we have discussed into a single conclusion. And that layer is scale. Human intuition evolved on a planet distances were measured in meters, then kilometers, then maybe the span of a horizon. Even astronomical intuition, historically, stopped at planetary systems. The universe operates on scales that erase intuition completely. A single star may shine for billions of years. That sounds eternal, but compared to cosmic time, it is brief. A galaxy may contain hundreds of billions of stars. That sounds overwhelming, but compared to cosmic volume, it is sparse. When people imagine space filled with stars, they imagine density. In reality, the defining feature of the universe is emptiness. Most of the cosmos is vacuum, not empty in a philosophical sense, but empty in a physical one. Few particles, few photons, few interactions. Even within galaxies, the average distance between stars is so large that light from one rarely meaningfully overlaps with light from another. Outside galaxies, those distances become almost absurd. So the darkness you see is not a failure of illumination. It is the natural visual expression of extreme scale. Brightness requires proximity. Darkness is what happens when everything is far apart. And distance does not only weaken light. It reshapes meaning. On Earth, a light source usually implies relevance. A lamp illuminates a room. The sun defines day. In space, light does not imply presence. A star can exist and be completely irrelevant to your local environment. Its photons may never reach you, and if they do, they arrive diluted, delayed, and transformed. So cosmic light is not personal. It does not care if it is seen. Now consider the combined effect of everything so far. Finite age, finite stellar lifetimes, inverse square dilution, spectral shifting, cosmic expansion, perceptual thresholds. Each one alone reduces brightness. Together, they crush it. The universe is not dark because it is inefficient. It is dark because it is honest. It does not concentrate energy where perception expects it. It lets energy spread freely, and this spreading is irreversible. Once light is stretched into longer wavelengths, there is no cosmic mechanism that gathers it back into visible form. No lens, no mirror, no reversal. The universe remembers its past in colder, weaker radiation. It is translation. Now think about time once more, but this time from the opposite direction. Not the past, the future. As the universe continues to expand, galaxies drift farther apart. Eventually, even light from nearby galaxies will redshift beyond visibility. Future observers, if any exist, will see fewer stars, then fewer galaxies, then only their local group, then maybe only their own galaxy. After that, even starlight itself will fade as stars exhaust their fuel. The night sky of the far future will not resemble ours. It will be quieter, simpler, darker. Not because the universe died, but because it matured. This means something profound. We live in a relatively bright era. The darkness we see now is not maximal. It is transitional. The stars we see are survivors of timing. They exist in a narrow window when stars still form, galaxies are still visible, light still arrives in the visible spectrum. That window is closing slowly, but inevitably. So the night sky is not a permanent feature of reality. It is a snapshot, and darkness is increasing. That does not make the universe tragic. It makes it directional. Cosmic evolution has an arrow, and that arrow points away from visibility. This reframes Olber's paradox completely. The paradox assumes a universe that does not change, but change is the only constant. Once you accept evolution of stars, space, energy, and time, the paradox dissolves. Darkness is no longer confusing. It is expected. And yet, there is still one emotional resistance left. People often feel that darkness implies insignificance. Every visible star is a coincidence of geometry and time. Every dark region is simply where coincidence did not occur. So the night sky is not telling you that nothing is there. It is telling you that presence does not guarantee visibility. This is a difficult idea to internalize. We instinctively associate existence with appearance, but the universe does not. Most of reality is invisible. Always has been. The stars are not the rule. They are exceptions. And darkness is not the void between exceptions. It is the baseline state. Once you see that, the blackness of space stops being eerie. It becomes calm, neutral, unbiased. The universe is not hiding. It is simply not speaking in light your eyes understand. Darkness is not silence. It is a language you were not built to hear. And this prepares us for the final step. Because once darkness is understood, as a consequence, not a mystery, the real question shifts. It is no longer, why is the sky dark? It becomes, what does the darkness tell us about our place in time? That answer lies ahead. When all explanations are stripped down to their core, the darkness of the night sky stops being a puzzle about missing light. It becomes a statement about position. Not position in space, but position in time. Every observer exists at a specific moment in the universe's history, and that moment defines what can be seen. We tend to think of reality as something fixed, as if the universe presents the same face to every observer, everywhere, always. But that is not how cosmology works. The universe has chapters, and vision depends on which chapter you inhabit. We live in an era where stars still burn, galaxies are still close enough to be seen. Invisible light has not yet fully slipped into invisibility. This is not guaranteed. It is temporary. The darkness of the sky is evidence that the universe had a beginning. But the stars you do see are evidence that the universe has not yet reached its end. This makes our moment unusual. Too early, and there were no stars. Too late, and the stars would be gone. Darkness exists because we are balanced between those extremes. That balance is fragile. As time progresses, the visible universe shrinks, not physically, informationally. Fewer photons arrive in the visible range. Fewer structures remain observable. More of reality moves beyond perceptual reach. Eventually, observers, if they exist, will inhabit a universe where darkness is nearly complete. Not because matter vanished, but because connection did. This introduces a subtle but powerful idea. Visibility is not a property of existence. It is a property of alignment. Alignment between source and observer, wavelength and biology, distance and time, expansion rate and energy. When those alignments fail, darkness appears. So the night sky is not asking why the universe exists. It is asking why we exist now. Because now is when light still speaks. This perspective dissolves the emotional discomfort many people feel about cosmic darkness. Darkness is not hostile. It is not cold indifference. It is neutrality. The universe does not prioritize observers. It does not ensure clarity. It does not guarantee illumination. It simply evolves, and that evolution naturally leads toward darkness. The stars do not disappear violently. They fade. They exhaust fuel. They become remnants. Galaxies drift apart. Light stretches. Energy spreads thin. Undramatic. Nothing catastrophic. Just continuation. And continuation does not favor brightness. Brightness is a phase. Darkness is the default. Once you understand this, the night sky becomes honest rather than unsettling. It is not pretending to be empty. It is showing you limits. Limits of reach, Limits of time, limits of perception. The black background above you is not hiding secrets. It is revealing boundaries. Every dark region marks a place where light has not arrived. Light has moved beyond visibility. Light existed before stars formed. Light belonged to stars that no longer exist. The sky is not missing information. It is mapped by information loss, and that loss is not failure. It is structure. Physics does not preserve visibility. It preserves consistency. So when people ask why the universe isn't flooded with light, they are really asking why reality does not cater to intuition. And the answer is simple. Intuition evolved locally. The universe did not. We are small creatures in a vast system, equipped with narrow senses, living in a temporary window of visibility. Darkness is what surrounds that window. This realization does not diminish humanity. It contextualizes it. We are not central. We are not early. We are not late. We are brief. And the stars we see are companions in that brevity. They shine while they can. So do we. The night sky, then, is not a question. It is a record. A record of expansion, of aging light, of finite lifetimes, of geometry overpowering abundance. Darkness is not a flaw in the universe. It is the universe obeying itself. And once that is understood, there is nothing unsettling left. Only clarity. The sky is dark because it should be. And the light that remains is a gift of timing.